There is no code that explicitly permits splicing a ground conductor within an electrical panel. The primary goal of grounding systems is to provide a low impedance path for fault current, ensuring that overcurrent protective devices, such as circuit breakers or fuses, operate quickly to clear a fault. Splicing ground wires inside an electrical panel can potentially introduce points of high resistance, which could compromise the effectiveness of the grounding system. A compromised grounding system increases the risk of electrical shock and fire hazards. The National Electrical Code, or NEC, provides guidelines for proper grounding and bonding practices. While it doesn't explicitly prohibit splicing ground wires within a panel, it emphasizes the need for permanent and continuous grounding connections. Section 250.8 addresses the connection of grounding and bonding equipment. It requires that these connections be made in a manner that ensures a reliable and permanent electrical connection. Wire nuts or twist-on connectors are generally not considered suitable for grounding connections in electrical panels due to their potential for loosening over time, which could create a high resistance connection. Approved methods for connecting grounding conductors include using listed grounding bars, terminals, or reversible compression connectors. Grounding bars provide a central location for terminating ground wires, ensuring a secure and reliable connection. These bars are typically bonded to the metal enclosure of the electrical panel, providing a direct path to ground. When multiple ground wires need to be connected, it is best practice to use a grounding bar with sufficient terminals to accommodate all conductors. Each ground wire should be individually connected to the grounding bar using a listed terminal or connector. Avoid stacking multiple ground wires under a single terminal screw, as this can compromise the connection and reduce its effectiveness. Reversible compression connectors provide a permanent and reliable connection for grounding conductors. These connectors are typically installed using a specialized crimping tool that compresses the connector onto the wire, creating a gas-tight seal. Once installed, reversible compression connectors cannot be easily removed or loosened, ensuring a long-lasting and secure connection. When working with grounding systems, it's crucial to adhere to all applicable codes and standards. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns. Proper grounding and bonding are essential for electrical safety and help to protect people and property from the hazards of electrical shock and fire. In summary, while there is no code specifically stating that ground wires can be spliced in an electrical panel, the intent of the code is to maintain continuous and reliable grounding paths. The prohibition stems from the risk of creating high resistance connections through splicing methods like wire nuts, which are not considered permanent or reliable for grounding purposes. Always use approved grounding bars, terminals, or reversible compression connectors to ensure a safe and effective grounding system. It is important to note the difference between grounding and bonding. Grounding refers to connecting electrical circuits and equipment to the earth. Bonding, on the other hand, involves connecting non-current carrying metal parts of electrical equipment to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety. Section 250 of the NEC covers the requirements for grounding and bonding. This section provides detailed information on the types of grounding and bonding conductors that are permitted, the methods for connecting these conductors, and the sizing requirements for grounding and bonding conductors. Proper grounding and bonding helps to minimize the risk of electrical shock, reduce the likelihood of fire, and ensure the proper operation of electrical equipment. When installing or modifying electrical systems, it is essential to follow the requirements of the NEC and other applicable codes and standards. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns. Splicing is generally discouraged on ground wires due to the requirement of a continuous, low impedance path to ground. The NEC aims to minimize any potential points of failure or increased resistance in the grounding system, which is crucial for safety. If a ground wire is too short, it should be replaced with a single continuous wire of the correct length rather than spliced. Using appropriately sized and listed grounding conductors is also paramount. The size of the grounding conductor is determined by the size of the circuit's overcurrent protection. NEC Table 250.122 provides guidance on selecting the proper size of the grounding conductor based on the rating of the circuit breaker or fuse. Proper grounding and bonding are critical for electrical safety. By following the requirements of the NEC and using approved methods and materials, you can help to ensure a safe and reliable electrical system. Grounding is about providing a path for fault current to return to the source, allowing the overcurrent device to trip and clear the fault. It also helps to stabilize voltage to ground, reducing the risk of electric shock. Bonding ensures that all metal parts within an electrical system are at the same potential, further reducing the risk of shock. The grounding electrode system, which includes the grounding electrode conductor and the grounding electrodes, is a crucial part of the grounding system. The grounding electrode conductor connects the equipment grounding system to the grounding electrodes, such as ground rods, metal water pipes, or concrete encased electrodes. The grounding electrodes provide a connection to the earth, allowing fault current to dissipate safely. Regular inspection and maintenance of the grounding system are essential to ensure its continued effectiveness. Check for loose connections, corrosion, and damage to grounding conductors and electrodes. Any issues should be addressed promptly to maintain the integrity of the grounding system. When working with electrical systems, always de-energize the circuit before making any connections or modifications. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electricity, it is best to hire a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from injury. Consider a scenario where a ground wire is improperly spliced using a wire nut inside an electrical panel. Over time, the wire nut may loosen due to vibration or temperature changes, creating a high-resistance connection. If a fault occurs in the circuit, the fault current may not be able to flow back to the source quickly enough, which could prevent the circuit breaker from tripping. This could result in a dangerous voltage on the metal parts of electrical equipment, increasing the risk of electric shock. In addition, the high-resistance connection could generate heat, which could potentially lead to a fire. By avoiding splicing ground wires and using approved grounding methods, you can help to prevent these hazards and ensure a safe and reliable electrical system. The code also covers requirements for identifying grounding and grounded conductors. Grounding conductors are typically green or green with a yellow stripe, while grounded conductors are typically white or gray. These color codes help to ensure that electricians can easily identify the different types of conductors and make the correct connections. When extending existing circuits, it is important to maintain the integrity of the grounding system. If the existing grounding conductor is too short, it should be replaced with a longer conductor rather than spliced. Use approved grounding methods and materials to ensure a safe and reliable connection. It's very important to ensure that the electrical panel itself is properly bonded to the building's grounding electrode system. This is typically accomplished by connecting a grounding electrode conductor from the panel to a grounding electrode, such as a ground rod or a metal water pipe. The grounding electrode conductor should be sized according to NEC Table 250.66. Based on the size of the service entrance conductors. Another thing is that surge protective devices, or SPDs, are often installed in electrical panels to protect sensitive electronic equipment from voltage surges. SPD should be properly grounded to ensure that they can effectively divert surge current to ground. The grounding conductor for the SPD should be as short and straight as possible to minimize impedance. Electrical inspectors play a vital role in ensuring that electrical installations comply with the NEC and other applicable codes and standards. Inspectors review electrical plans, inspect electrical work, and issue permits to ensure that electrical systems are safe and reliable. If you are planning to install or modify an electrical system, it is important to obtain the necessary permits and schedule an inspection with your local electrical inspector. Another important point to remember is that aluminum conductors require the use of approved connectors and terminals that are specifically designed for use with aluminum. Aluminum connectors and terminals are typically marked with the letters ALCU, which indicates that they are suitable for use with both aluminum and copper conductors. Using the wrong type of connector or terminal can lead to corrosion and failure of the connection. This can create a high-resistance connection and increase the risk of electrical shock and fire. Additionally, electrical metallic tubing, or EMT, can be used as a grounding conductor under certain conditions. The NEC specifies the requirements for using EMT as a grounding conductor, including the size and type of EMT that is permitted. EMT must be properly connected to the electrical panel and to the metal enclosures of electrical equipment to ensure a continuous grounding path. When installing electrical systems in damp or wet locations, it is important to use watertight fittings and enclosures to prevent moisture from entering the system. Moisture can cause corrosion and deterioration of electrical components, which can lead to electrical shock and fire hazards. Use only listed and labeled electrical equipment and materials. Listed and labeled equipment has been tested and certified by a recognized testing laboratory to meet safety standards. Using unlisted or unlabeled equipment can be dangerous and may violate electrical codes. Always follow the manufacturer's instructions when installing electrical equipment and materials. The manufacturer's instructions provide important information on how to install the equipment safely and correctly. Improper installation can lead to electrical shock, fire, and equipment damage. The NEC is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest edition of the NEC to ensure that your electrical installations comply with current standards. Many states and local jurisdictions adopt the NEC as their electrical code. Check with your local authorities to determine which edition of the NEC is in effect in your area. Continuing education is essential for electricians and other electrical professionals. Continuing education courses provide electricians with the opportunity to learn about new technologies, code changes, and best practices. Staying current with the latest knowledge and skills helps electricians to provide safe and reliable electrical services. Never work on electrical equipment while standing in water or on a wet surface. Water is an excellent conductor of electricity, and standing in water can increase the risk of electric shock. Wear rubber-soled shoes and use a rubber mat to insulate yourself from the ground. Avoid wearing metal jewelry or clothing while working with electricity. Metal can conduct electricity and increase the risk of electric shock. Use insulated tools when working with electricity. Insulated tools provide a barrier between you and the electrical current, reducing the risk of electric shock. Always double-check your work before energizing a circuit. Make sure that all connections are tight and that there are no exposed wires. If you are unsure about any aspect of an electrical installation, it is best to consult with a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from injury. Another thing is ground fault circuit interrupters, or GFCIs, are life-saving devices that protect people from electric shock. GFCIs are designed to detect ground faults, which occur when electricity leaks from a circuit to ground. When a GFCI detects a ground fault, it quickly shuts off the power to the circuit, preventing electric shock. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Test GFCIs monthly to ensure that they are working properly. To test a GFCI, press the test button on the device. The GFCI should trip and shut off the power to the circuit. To reset the GFCI, press the reset button. Arc fault circuit interrupters, or FCIs, are another type of circuit breaker that protects against electrical fires. FCIs are designed to detect arc faults, which are dangerous electrical arcs that can occur in damaged or worn wiring. When an FCI detects an arc fault, it quickly shuts off the power to the circuit, preventing a fire. FCIs are required in many locations, such as bedrooms and living rooms. If you have any questions about grounding or bonding, or any other aspect of electrical safety, it is best to consult with a qualified electrician. A qualified electrician can provide you with expert advice and guidance to ensure that your electrical system is safe and reliable. Remember that electricity is a powerful force that can be dangerous if not handled properly. Always take the necessary precautions to protect yourself from electrical shock and fire. Proper grounding and bonding are essential for electrical safety, and it is important to follow the requirements of the NEC and other applicable codes and standards. When working on electrical systems, always prioritize safety. De-energize circuits before working on them, use appropriate personal protective equipment, and consult with a qualified electrician if you have any questions or concerns. By following these guidelines, you can help to ensure a safe and reliable electrical system.